Because how would I know that it's going to the left of the smaller one when I only have one in there? So typically when you add a sequence of values into a tree, you would put two values in. You put the first value in, that would create a root. Then you put another value in, that would also go in the root. And it would be smaller and larger. The third value coming in, the third key coming in, would go either to the left if it's smaller than the smaller. If it's between the smaller and the larger, go here. If it's bigger than the larger, it would go here. Does that make sense? So the number of keys and the number of nodes is different, and I explained that in section C. Okay, so now, what we would have if we went to n equals, so this is very similar to the approach we took in class. So if the number of nodes is going to be 3 nodes, right? Well, I guess we're still talking about it. Are we still talking about it? I'm almost like confusing myself the way we're doing it, because there's like two really things going on here. With 3 nodes, there's a lot of options. So because if you have a third node, if you've had put a third node here, your height doesn't change, but this changes. So was our analysis that we did in class, I think that was, I think it was based on height.
If you do with height, and you can do with height that equal to 3, I mean, so complicated.
Yeah, so it's just, I mean, there is a lot of ways to attack this problem. So the way we did it in class, we would take this one and then we'd create, instead of 2, we could create 3 subtrees. And then we would assume there would be 2 nodes underneath here somewhere. So you could have 2 nodes, you could have 0, and then you could have 0, and then you could have 2. Or you could have 0, 1 and 1, or you could have 0, 2, and 0. So basically the sum of them has to be equal to 2. If you had a 1, you could have a 1 here, or if you have a 1, you could have a 1 here. Okay, or you can have a 0 here, and you would have 1, 1. Then you can multiply all of these, because all these already done, all these already have values here. So that's one way of looking at it. Another way of looking at it, so that's I'm not even sure exactly what the analysis here is. So basically, if you went in this direction, and if you did some reasonable work, I just gave you credit for it. Another way you can look at it is purely from a standpoint of height. So this is, I look at this as the number of nodes. And if you just look at it from the standpoint of height, then what you have is height, when height is equal to 0, that means you have no nodes, and there's only one way of that shape to look like. When you have a height of 1, then you have a root node that's also going to be 1 again. But if you have a height of 2, then you have to first of all have a root, right? And then you could have one child that's a height of 2, but you could have a middle child, or you could have a right child, but to preserve a height of 2, you could also have 2 children. So 2 children means that you could have, for example, a left and a middle, but no right. You could also have a left, no middle, but a right. Or you could have no left, but a middle and a right. And lastly, so this is basically how you can have only one child. This is how you can have 2 children with a height of 2. And finally, you can have 3 children. There's only one way to have 3 children. That's to have a left. This gives you 1, 2, 3, 4, 5, 6, 7. That gives you 7 total shapes with a height of 2. Now, when you go to height of 3, things get really crazy. They get crazy really fast, like surprisingly fast. So here's what it looks like. So let's say, so this is height of 1, height of 0, height of 0, height of 1, height of 2. Let's consider height equal to 3. When height is equal to 3, basically what it means, you have a root. You always have to have a root. And you're still going to have 3 subtrees. But I'm going to make these subtrees very, very large. Very large. You're going to see why in a minute. So it's just a lot of work. Okay, let's move the root so it's centered more. And then it's going to look kind of like that. So these are the subtrees. And so basically, what can happen is, in order to get a height of 3, you have to have a height of 2 in at least one of the subtrees. Does that make sense? So, for example, let's say the left subtree has a height of 2. So with the root, that's 3. So the middle subtree and the right subtree could be any height, including 0, 1, or 2. Doesn't matter. So therefore, 2 can be mixed with 0, 0. 2 can also be mixed with 0, 1, or 0, 2, or 1, 0, or 2, or or 1, 1, or 1, 2. So that gives us 6 possible ways. Is there any other way we can mix 2? No, because basically this is going to be all the numbers from 0, 1, and 2, so it's going to be, you have 3 choices. Is there any more? 2s? I do have 2s, yeah, I have 2. So this could be 2, so 2, 0, right, 2, 1, and 2, 2. So that gives us, yes, so that's it for 2. So if you have 2 in the left subtree, then the middle tree and the right tree could have anything. Now, see why I made these trees so tall? So let's say you only had a height of 1 on the left one. Then it means you can have anything in the middle of right as long as one of them is a 2. So for example, if we start with 0, then what does this have to be? It has to be a 2. Why? Because if you don't have a 2, you won't have a height of 3. So you can have a root, height of 2, height of 0, and height of 1. That makes a 3 because this path from here to this subtree is 3. Freeze the 1, and now we're going to go 1. But then if you have a 1 and a 1, in order to get a height of 3, you still have to get a 2 here. Okay? So that's 1 with 0, 1 with 1. Okay, so now we're going to go 1 with 2. If you have 1, you can have 2. Now, if you have 2, then this one can now have anything it wants to. It can have 0, 1, or 2, so therefore we can match this with 1, 2, 0, or 1, 2, 1, or 1, 2, 2. So all of these are unique. And the last one, I already ran out of room, is if the left subtree, so I'll continue the subtree here, subtrees here. The last one is if there's 0 height on the left subtree. One of them has to have a 2, so if I start with 0, what does this one have to have? It has to have a 2. If I have, so this is all the ones that the left subtree is 0. So 0, so let's go to 1. What does this have to be? It has to be 2. If I have 0, I can also have no, remember, if it's 0, 0, 2 is the only choice. Only choice. But if I have this, now I have the required height in the middle subtree. So I could have a 0 here, or I could have a 1, or I could have a 2. Right? That's a lot of stuff, right? So if you mix it up, 3, 4, 5, 6, 7, should be 9. Go ahead. For some reason I have 8, it should be 9. 2, 3, 4, 5, 6, yeah, it's 9. Oh, these are not numbers, these are just dots. So they're 9. Now, let's look at this line across. How many shapes do we have with the root and this configuration? Well, shapes, how many can you have shapes with height of 2? 7. How many with 0? So total of 7 times 1 times 1. This is always going to be 2, so this is going to be 7 again. This is going to be, this is going to be 49. Why 49? Because this can be, this can go in 7 ways, this can go in 7 ways. So 7 times 7 is 49. Okay, continuing here, we have 7, 7. We have 49 again. 49 again. 49 again, and this time we have 7 and a 7 and a 7. So it's going to be 7 to the third power, which is 343. Okay, that takes care of the case where all of these guys are 2s. When they're 1s, what's the product here? 7, 7, 49? No. 7, 7, still 7. 7, 7, and 49. And on the last one, we're going to have 7, 7, 7, 7, and 49 again. So if we add all this up, we find that we have 12 7s. You can count them up yourself. Plus we have 6 49s and a single value of 343. That occurs when you have height of 3, height of about 2 in all the subtrays. So if we add this all together, we'll end up getting with 721. Which is a nice number, big number. So at 4, we have 721. Okay? Now, whereas the formula for the other one is not that difficult, it's not easy, the double summation. Here, the formula is much more difficult because there's logic involved. For example, if you have a 2 here in the first one, then essentially the summation can go through, if I is equal to 2, then j and k can range from 0 to 2, 0 to 2 independently. But when I is equal to 1 of the values must be 2. The other one can be anything. And if I is equal to 0, again, one of the values has to be 2. And the other one can be anything. So here's the case where this one is 2, 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 and this one is 2, because it can be anything. But one of them has to be equal to 2. Notice that when this one is 2, these don't necessarily have to have a 2. They may have a 2 or may not have a 2. So that's what it is. So can you imagine going to now height of 4? So this just shows you that if you have a height of 3, so you have a tertiary tree. Now a full tertiary tree of a height of 3 would look like this. This is not that complicated, which I think I asked you to draw on the next one. And most of you did a good job with that. So that would be the tertiary tree, right? Right? How many nodes does it have? 13 nodes. So that is a full tree, and that's the tree that correlates to this. Right? That's this tree right here. But we know that we can have a total of 7 shapes here when we have a height of 2. And 7 shapes here, 7 shapes here. So this tree, which right now has a height of equal to 3, there are 720 other trees with different shapes that are the same height here. That's it. So again, did I expect you to do this? Absolutely not. Because number one, it takes too much time. So I wouldn't expect you to do something like that. It's just not enough time on a test to do it. So it kind of pushed you a little bit further than I wanted to push you, so I didn't really grade it very hard. As long as you went in one of the correct directions, fine. And I certainly wouldn't expect to see this or to see even the double summation for the other one. As long as you were able to understand that we're either considering the number of nodes being added or the height being considered, then this is kind of what we got. Okay. Any questions? All right, so some of you did a good job on the test. Some of you need to improve. for next time. Tests are very important, you know, for your grades, so try to improve. I try to look at the distribution of grades, try to look at the median grade. The median grade is very important for me. Median grade is the middle grade, not the mean, but the median, the centigrade. I try to give people around the median, you know, in the area of a B, because I push it a little bit lower. But try not to push me too hard, because then I won't be able to give you a B. Everybody wants to get at least a B in the class, right? So, all right, so it's very important in the next test that you guys do a little better job. I'll try to give you questions that are going to be a little bit more focused. I think these were good questions. I think this question was the only one that kind of went a little bit places. But fortunately for us, it was only one question, one part of one question. But it could take you a lot of time if you get stuck on it. So, rule of thumb, if you get really stuck on something for a long time, move on to something else. Don't spend too much time on one question, because you know, it's not going to have any more credit necessarily than any other question.
Question 2A.
Huh?
The question 2A.
2A, yes. That is question 2A. So basically, if you came up with we're only looking for solutions for 0. I was only looking for 0, 1, and 2. And I didn't expect you to generalize your answer.
No, I mean the question 2.
Oh, 2A, I'm sorry, okay. Didn't we talk about 2 last, okay, you didn't discuss, okay. What's 2A? Yes. Uh-huh.
What's the final answer you get? The log of Paul.
So oh, yeah, I never, okay, I have to correct that. Final answer should be n squared, theta n squared log squared n. Okay, so I told you that last time, so I kind of forgot that I was, for some reason I put a cube in there, it should be squared. So if you have it squared, just pass your test in and I'll review that, I'll regrade that. Okay, so if you have a squared and I took off because it wasn't cubed, I'll take it back. Anybody who's got it? Just pass your papers, pass your papers forward and I'll grab them. Yep, thank you for reminding me. I forgot about that, that would have been so easy to do. Now I have to do it again. Yeah.
And the last one,
Yeah.
I got 25, so I thought you took off 22.
Well, I didn't take off points, I only took off 2 points, this is the bottom, this is everything. Okay, I did see that. Can you explain to me what you did here? I guess it didn't click with me very quickly what you were doing.